Hey everybody, Lars here. Wanted to hop online real quick tonight and do the second review video for Unit 1. It's actually Wednesday night. I recorded this a little early because I know I might be watching basketball tomorrow, and I've got something to show you. I am going down to Brick Township on Friday and doing a presentation for high school students, showing them how to create video games with Python. And this is a game that comes from a book about creating games with Python. I think the original game is called Nibbles. Uh-oh, I almost blew it. There we go. Boom. But it's called Wormy in this context. And basically what you have to do is you can't stop the worm, but you can control what direction it goes in. And every time you eat the apple, you get one segment bigger. And you keep going and going until you get really long. Now I've slowed it down considerably. If you play faster, it gets more fun. Okay, so game over. So when we get near the end of the course, is that going to end properly for me? No. I'm going to show you the game. It's not very long, maybe 115 lines. It's all written in Python, and you're going to understand it all. It's not going to be something that you will not understand. But for the time being, let me get rid of this. Probably not the right one. Let me just crash this. Yes, I will kill it. All right, good. Now, yay, I have what I have running. All right, let's get started looking at what we want to look at, and that's the second part of your Unit 1 slides, which has to do with Booleans, a little bit about Boolean algebra, and then a little bit about if-then else. So, like I always do, I'm going to take this file, and I'm going to put it up on Sakai after I'm done with it. And one of the things I do for you, if you can look up in the comments there, is I have all the relational operators up there for you. So you can start getting used to what you can do with the different relational operators. Just to show you right out of the gate, actually we want to use a capital. That is a series of Boolean variables. You can see that idle has changed true and false to the color orange. That kind of denotes that it's a keyword. You can't use it for variables, names, or other names. You have to, use it for true or false. And Boolean variables are special variables that can either be true or false. So if you print them out, you'll see that you get true when you print var1, and if you print var2, you get false. Okay, not really the most important thing in the world when you do something like that, but the reason we have Booleans and the reason we have the relational operators is because we want to do something like this. Let's say we had two numbers, and let's pick the least creative variable names on the planet, num1 and num2, and I guess I'll make that 20. Now we see what Booleans are really all about. Let's say we want var3 to equal num1 greater than num2. So, print var3. Is number 1 greater than number 2? Let's see, is 10 greater than 20? No, it is not. So variable 3 will be false. That relational operator is used, the expression is evaluated, and variable 3 gets a Boolean value of false. Let me run the program and show you that, see? Okay, now if we change the sign and make it less than, well, now things are true. So as you can see, we get a true there. Okay, if we say equal to, now you can see I did 2 equal signs, not 1, because in Python 1 is an assignment. When we talk about equality or equal to, as far as relations are concerned, we use 2 equal signs. I think that's going to be false because they're not equal to each other. But I can also test if they are not equal to each other. This, of course, is going to be true. Okay? And then you can use greater than and equal to, less than equal to, and things along those lines to create different relations and create your Boolean variables. So that's how you create a Boolean variable, by having two numbers. You don't even have to have the variables there. You can always just, is 10 not equal to 10? That will be false, because they are equal to each other, and things along those lines. All right, so that is as simple as Booleans can be. Now, what's something that we can do with Booleans? Let's say, call this if-then. Let's say I say if var3, then I hit a colon and I hit enter, print, this is true, else, why did I do that? That's what I want. All right. So it's the first time we're seeing this, so let's take a look at it. I use an if, and I say if var3. So depending on whether var3 is true or false, if it's true, I run this statement right here, right underneath it. You'll notice, and you read in your thing, I think at the beginning of the slides, I've indented 4 here. This is how Python does blocks. So you denote a block or something new with 1, 2, 3, 4 spaces. So when I use that if, I want to execute a block of code if it's true. In this case, it's only one statement, so it's not really a block. But if I wanted to, I could put a whole bunch of things there. As long as they're all indented 4, they'll all be in the same block. So if var3 is true, then print this is true. If it is not true, then I say else, which means if it's not true or if it's false, then I print this is false. So var3, num1 not equal to num2, that is true. So this is true should print. Let's see if we are right. And we are. This is true. Okay, let's get rid of this guy for the time being, because we don't really need it. Okay? We don't really even have to use the variables. We can create a condition ourselves. So if num1 is equal to, let's say, num1, which is going to be true, it's going to print this is true. Now, if I say if num1 is not equal to num1, that is false, because they're equal to each other. It's the same thing. So we should get the second condition, this is false, in that else condition right there. Okay? So what we've looked at so far doesn't seem that complicated. It seems kind of simple. We have Boolean operations, and then we have these conditional operators where we can look at variables or numbers and compare them to each other and create Boolean variables. And then down here, we've tested that. And depending on what we got, true or false, we've made a decision on what to do. And that doesn't, in the context where we just did it, it doesn't seem like that big a deal, but it is a very big deal. You just made a decision. You just created a relation, got a value, and evaluated that value, and then made a decision based on it to do something. And that's an important concept in computer programming, because you're going to take input from users, or you're going to create variables, and you're going to do a whole bunch of things, and you're going to make decisions based on what your numbers are. Okay? One last thing that I'm going to show you. Well, no, I'm going to show you a couple more things. We can also use, let's see, num2 equal to num2. Okay, we can also use Boolean algebra to create more complex conditionals that have to be evaluated. So when I have an and, both of these conditions have to be true in order for the condition to be true and this is true to be printed. So let's see, num1 not equal to num1, that's not true. So num2 equal to num2, that is true, but it's not going to matter. Watch. This is false. And the reason it's false, let me get this up here so we can see it better. And the reason it's false Is that down the bottom? Yes, it is. Is because with an and, if only one thing is false, it blows the whole thing up and everything is bad. If we change that and to an or, well, now we've got a different story because only one has to be true. And it turns out in this case, this one is. Okay? If you want your and to work, and I'll show you one where it does, we want to make sure both sides are true. So if you want to test for multiple things to be true, and if they're all true, you do something, that's what you would use in and. So num1 equal to num1? Yes. Num2 equal to num2? Oh, yes. So that and is true in this case, and we get this is true. Okay? Now, I'll show you one more thing. Let's say we had this condition right here, and we run it, and it's false because this side is false, right? We could also, if we wanted, and I usually do this with parentheses just to keep myself sane, is use a not or a negation so that whatever the value inside here is, the total will be the opposite. So when this comes in false, this not will make it all true. So this and is going to be true again because I've reversed the value. See, this is true. I've reversed the value of that one right there. Okay? So when you're dealing with Boolean algebra, you're dealing with and, you're dealing with or, and you're dealing with not. It comes in handy when you create conditionals, and you're going to see it's going to come in handy for you when you do your second homework assignment, which I'm going to put. Well, actually, you're getting this video, I think, Thursday night, which means I should have posted the homeworks already. So you should be good to go as far as having the homeworks. I wanted to make sure you guys had everything. Even though I'm probably going to do one more video over the weekend, just to really quick whip up a program and show you how to start it from scratch and do something similar to the homework, not the homework, but something similar. So Boolean algebra is going to come into play there. Okay, so now we've seen relational operators, we've seen Boolean variables, we've seen how to create Boolean variables and then test them with if-then. Now we've seen a little bit of Boolean algebra. There's really only one thing left that I want to show you, and hold on, I'm going to zotz all this out real quick while I show you this. What am I going to call this? I'm going to call this watch for binary choices, because this sometimes messes people up. I am going to grab a variable called num3. I'm going to make it equal to 12. Okay. What am I going to do for an if statement? If num3 is greater than 10, I am going to print this. Oh no, why don't I just do this? Num3, comma, is greater than 10. Tell the truth. Give the people what they want. Else, print num3 is less than 10. Bingo bango. Okay, so now I've set a variable and I created a little condition there. If else, I'm going to check my number versus 10. If it's greater than 10, which it's going to be because it's 12, I should print greater than. And if it's less than 10, then it'll fall through and run the else print, and it'll say is less than 10. So let's test my little program. Yay, 12 is greater than 10. That's awesome. Okay, so right now things work. So let's try 8. I save and I run. 8 is less than 10. Awesome. It works. Now, have you figured out the problem? Because there's a problem here. And what is our problem? Our problem is this. 10 is less than 10. That obviously is not true, because logically we have a problem here. And our problem is that we're testing greater than, not greater than or equal to. So we do not have a binary situation here. We do not have an either or. Okay? We have three possible things here. We could be greater than, we could be less than, or we could be equal to. So what do I do with an if structure if this comes up? This is where we use something called an elif. which allows us to create a secondary condition. What I'm going to make the secondary condition is if num3 is less than 10, print num3 is less than 10. Then I'm going to do an else, and then I will print num3 is 10. Because think about the logic. I've tested if it's greater than 10. If that happens, great. We print is greater than 10 and we jump out of the loop. If not, then I go to the second test. Is num3 less than 10? If it is, great. I print is less than 10 and I jump out of the loop. Now, then I get to the final else. Think about it. We tested for greater than. If that didn't happen, then we tested for less than. If that didn't happen, the number has to be 10. Okay? So, let's go back and test our code. 12 is greater than 10. I love it. All right, let's go back. Boom, boom. Yeah. Okay, now is the real test. Dun, 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 dun. Dun, 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 dun. And of course, 10 is 10. So I do this little part for two reasons. One, I want you to see elif in action. Okay, elif is an important part of if-then decision structures because not everything's going to be a binary choice. Not everything's going to be black and white, 1 or 0. There's going to be, different things that you're going to want to look at different times. Again, second homework assignment, wink, wink, nod, nod. That's where you're going to find something along those lines. Also, that's the point is I wanted you to see the binary choices. Be careful, because sometimes you think something's a binary choice, and it's really not a binary choice. All right? All right. That is pretty much going to be it for the Python in this little one. Again, as I always do, save. I am going to save this file, and I'm going to put it up in your Sakai resources. I will probably do that tomorrow night when I release this video to you guys. So you are on Thursday, the 2nd day of June. A week before the end of the unit, you will have review video 1, review video 2, your slides, your Zell chapters, and you now will have your 2 assignments that hopefully over the weekend you can begin thinking about and putting some code together and trying to work on those things, all right? As of now, if you have any questions, please go post them in the forum because, you could also email me. Believe me, I have 0 problems with people emailing me and asking me questions. But if it's like a coding question or it's a question you think other people in the class might want to have answered, put it in the forums. That way when I answer it, I'll be answering for everybody. And everybody can see the answers to the different questions you have, all right? All right, it's only day 2. I know we're chugging along. I want to make sure that time-wise you guys have time to think and you have all of your resources and I'm not doing things late and getting you things late because usually your 2-week units are going to be 9-10 days in the summertime and your 3-week units are going to be 17-18 days in the summertime. And I want to make sure that you I'd rather front load your resources than try to time things out and get clever with things and blah, blah, blah. Nah, I don't want that. No good. I want you to be able to have everything, be able to swim around in it for a while and let you think and let you steep and let you understand this stuff. All right? So I'm going to get out of here. You guys have a good night. You should have a bunch of stuff. I'm going to be in Brick on Friday doing the high school thing, but I should be checking in online a couple times during the day, so you have no worries. No matter where I am, I'm going to be checking in on the class and answering questions and doing things. Like next week, I'm going to be in New Orleans for 3 or 4 days. I have to go present at a conference. Even so, I will be doing class. As a matter of fact, I think during our test, I will be on a plane. So it's one of the great things about a hybrid class. No matter where I am, I can check in. Last semester, we ran a quiz while I was in Memphis, and I did a whole bunch of stuff that way. So the hybrid comes in handy. Don't forget, Monday, June 6th, we are meeting in person, so make sure that's in your calendar. All right? All right. I'm getting out of here. I got to produce this video, and then I got to do some more gaming stuff, and then Bloodline on Netflix doesn't watch itself. So I've got work to do. All right. I'll talk to you guys later. Be good. Bye.